Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Algebra, in particular from ring theory, that appeared in the CSIR National Eligibility Test held on December 15, 2019. This question is related to the ideals in the ring of integers. This question is placed in part C, which is a multiple select question. There can be more than one answer and the question carries 4.75 marks. The question ID is 187-980-1823. This question is suitable for all these examinations. Right. The given question is, let I be an ideal of Z. Z is the ring of integers. Then which of the following statements are true? We are given four options. Option 1, I is a principal ideal of Z. Option 2, I is a prime ideal of Z. Option 3, if I is a prime ideal of Z, then I is a maximal ideal of Z. Option 4, if I is a maximal ideal of Z, then I is a prime ideal of Z. So this question is basically talks about the ideals of the ring of integers. Let's now discuss the solution of the problem in detail. We have Z, the commutative ring with unity. Let I be any ideal of Z. Let us take the option 1. I is a principal ideal of Z. Is it so? Yes, it is. Why? Because the Z plus dot, the ring of integers, is a commutative ring with unity, is a PID, principal ideal domain, in which every ideal is a principal ideal. That is, every ideal is generated by an element of Z. Hence, I is a principal ideal of Z. That is true. Now, let I be any ideal of Z. It is known that the Z plus dot, the commutative ring with unity, is a PID, principal ideal domain. That is, every ideal of Z is a principal ideal generated by some element A belongs to Z. Thus, I is a principal ideal. Right. So thus our option 1 is true. Right. We take option 2. I is a prime ideal of Z. Not necessarily. So if it is not necessarily, then we give a counter example. Right. Here is the definition of the prime ideal. To be a prime ideal, it must be a proper ideal, and the condition is whenever AB belongs to R and the product AB belongs to A, the ideal, imply A belongs to capital A and B belongs to capital A. Right. We consider I to be the ideal generated by 6, is the principal ideal. That is the set of all 6x belongs to all multiples, integer multiples of 6 are the elements of I. Right. Take two elements, 2, 3. The product 2 into 3 belongs to I because 6 belongs to I. But neither 2 belongs to I. 2 is not a multiple of 6, therefore 2 is not in I. 3 is not a multiple of 6, therefore 3 is not in I. But neither 2 belongs to I nor 3 belongs to I. Therefore, I is not necessarily a prime ideal. Therefore, option 2 is not true. Agreed. We move to the next slide, where we take option 3. If I is a prime ideal of Z, then I is a maximal ideal of Z. Not necessarily. Not necessarily. Let I be the ideal generated by 0, consisting of 0 element alone. Now, AB belongs to I. A into B belongs to I. That means I consists of only one element 0. Therefore, AB is 0. A and B are integers. A into B is 0. Either A belongs to I or B belongs to I. It's a proper ideal, right? So, it follows the definition of the prime ideal. Therefore, I is equal to the ideal generated by 0 is a prime ideal of Z. But is I a maximal ideal of Z? No, because there are many ideals properly in between I and Z. For example, I is the ideal generated by 2 is a proper subideal of bracket 2. The ideal generated by 2 is properly contained in Z. So, 0 is not maximal. Is not maximal. So also here, 0 is strictly contained in 3. Ideal generated by 3 is strictly contained in Z, and so on and so forth. There are many ideals like this. Therefore, our 0 ideal is a prime ideal but not a maximal ideal. So thus option 3 is not true. Now we ask the reverse question. If I is maximal, can I be a prime? If I is a maximal ideal of Z, then I is a prime ideal of Z. Yes, this is true, because in a commutative ring with unity, every maximal ideal is a prime ideal. So Z plus dot is a commutative ring with unity, and if I is maximal in Z, then I is a prime ideal, because in a commutative ring with unity, every maximal ideal is a prime ideal. We have Z, the commutative ring with unity. I is a maximal ideal of Z, and that implies I is a prime ideal of Z, because every maximal ideal in a commutative ring with unity is a prime ideal. Thus, option 4 is true. Summarizing all the options, the answer to this question is options 1 and 4. That is the detailed discussion of the solution of the given problem. Right. And this is a simple, straightforward question based on the ideals of Z plus dot. That is it a prime ideal? Is it a principal ideal? Is it a maximal ideal? So on and so forth. So, my advice to all the aspirants of NET is that, collect the information related to ideals like principal ideal, prime ideal, maximal ideal, and the results that are connecting these ideals. Make a good notes of it. And before the examination, going through that notes will be helpful for you. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I hope to meet you once again in another episode of learning. Keep learning. Enjoy learning mathematics. I wish you all the best. Thank you.